Now, entanglement swapping is a similar kind of thing to teleportation, but instead of teleporting a random state from one end to another end, in entanglement swapping, we swap two of the entangled and two of the shorter entanglement to a longer entanglement. So instead of having just two stations, we would assume three stations. First one is Alice, second is Bob. We are introducing another station, which would be a quantum repeater itself. Uh, so Alice has one qubit, the repeater has two qubits, the Bob has one qubit. Uh, Initially, we have an entanglement pair which is already there between Alice and repeater, one of the repeater qubit, and the other repeater qubit and the Bob qubit, which is 5 plus. Then same sort of analysis could be done. We can write the equation for the four qubits as follows, which is similar to what we have done in teleportation protocol. Now, similar to teleportation case, we have a table which is used for Bell state analysis for entanglement swapping. So given so now the measurement of qubits takes place at the repeater itself, and the measurement outcomes are sent to Bob. Now for psi plus, we would get AB in this fashion, which is precisely the entanglement pair we want. So we would apply a I gate, which basically does nothing. Similarly, for phi minus, we would have a phase correction is required. In this case, we would apply a poly Z gate, which would correct for that phase, and we would get a correct final state, which would entangle the NB qubit. Similarly, we have psi plus, which would need a bit flip. So we apply a poly X gate. We would have a correct entangled pair. Similarly, for psi minus, we need both bit flip as well as phase flip. So we apply a poly X gate and Z gate to extract out the correct final state. So in this way, the two initial EPR pair which are shared among Alice, the repeater and Bob are transformed into a end-to-end entanglement between two furthest station. So what we discuss is teleportation. Swapping is an extended version of teleportation. Now we can extend swapping by introducing more of repeaters and to construct a linear repeater chain. The process would be similar. Now, instead of just measuring at one repeater station, the measurement would take place at each of the repeater itself, and the collective measurement results would be sent to Bob. Then we can construct a Bell state analyzer for this setup, which would basically entangle the two farthest station, which is Alice and Bob.